Thank you very much. Welcome. Welcome to Perimeter Institute here in Waterloo, Ontario, Canada. And my name is Greg Dick. I'm the Director of Educational Outreach, and it is a pleasure to welcome everyone here, both those of you here in the Mike Lazaridis Theatre of Ideas and those of you watching online. Perimeter Institute would like to acknowledge that we are located on the traditional territory of the Attawandaron, the Anishinabeg, and the Haudenosaunee peoples. Perimeter Institute is situated on the Haldimand Tract, land promised to the Six Nations, which includes 6 miles on either side of the Grand River. Now, before we get to the lecture, I'd like to tell you about Secrets of the Universe. It's an IMAX 3D documentary made in association with Perimeter Institute. It premiered in the Smithsonian Institute in Washington, D.C. over the summer, and will be showing on giant screens across Canada and the globe over the next year. And I would like to say first that this project, like all of our educational outreach, is made possible through the generous public support from our governments of Ontario and of Canada, and our private support from donors like you. Now, to celebrate the launch of Secrets of the Universe, we are sending a lucky winner and a guest to Geneva, Switzerland, to go to CERN and go underground to see the Large Hadron Collider. I've been there, and it's awesome. So, if you want to enter these sweepstakes, do so by November 17th, 2019. Go to insidetheperimeter.ca/contest to enter. So that's insidetheperimeter.ca/contest. And for those of you watching online, you can join the conversation on social media. Our handle is @Perimeter and use hashtag #PILive. You can chat with Perimeter scientists throughout the talk, and I will also take questions, the online questions, for the Q&A at the end. And now, it is my pleasure to introduce tonight's very special guest speaker, Sir Martin Rees. Sir Martin Rees is the Astronomer Royal of the United Kingdom, and one of the world's leading minds in cosmology, astrophysics, and the existential crises that face us here on Earth. He is a former president of the Royal Society and master of Trinity College, Cambridge. He is the author of numerous books, including his latest book on the future, Prospects for Humanity. He'll be signing copies of his book after the talk in the atrium. And tonight, he will share perspectives on the global challenges we all face: environmental, societal, and technological, and explain how science can help us overcome them. Ladies and gentlemen, please welcome Sir Martin Rees.
Good evening, ladies and gentlemen. It's a great pleasure and privilege to be here. It was mentioned I have the title Astronomer Royal, and once I was asked, does this mean you do the Queen's horoscopes? And I said solemnly, if she wanted one, I'm the man she'd ask. And then this chap, who was an Indian tycoon, said, what are your predictions? And I said, stock markets will fluctuate, trouble in the Middle East, and other surprising things like that. And he took me seriously, but I then came clean and said, I'm only an astronomer. And he then lost all interest in my predictions. And rightly so, because scientists are rotten forecasters, although not quite as bad as economists. But despite all this, I have written a book with a rather pretentious title, On the Future. But my forecast tonight will be rather tentative, especially in front of an audience where there are people with far more expertise than me. The theme of my book is really this. The Earth has existed for 45 million centuries. But this century is special. It's the first when one species, ours, has the planet's future in its hands. We're deep in the Anthropocene. We could irreversibly degrade the biosphere, or we could trigger the transition from biological to electronic intelligences, or misdirected technology could cause a catastrophic setback to civilizations. But even with a cloudy crystal ball, there are some things which we can predict a few decades ahead. For instance, by mid-century, the world will be more crowded. 50 years ago, world population was about 3.5 billion. It's now about 7.7 billion. The growth's been mainly in Asia and Africa, as shown in this map, where regions are scaled in proportion to the amount of growth in the last 25 years. But the number of births worldwide peaked a few years ago and is actually now going down. Nonetheless, world population is forecast to rise to about 9 billion by mid-century. And this is partly because most people in the developing world are young, owing to recent growth. And they will have longer lifespans than their predecessors, so the histogram on the left, with lots and lots of young people, will become rather more like that on the right, which shows Western Europe. And the main growth is in East Asia, and it's there that the world's human and financial resources will become concentrated. And I think we can look forward to the end of 4 centuries of North Atlantic hegemony. And there's more urbanization. To prevent megacities becoming turbulent dystopias will surely be a major challenge to governance. To feed 9 billion people by mid-century will require further improved agriculture, low-till, water-conserving and GM crops, and maybe some dietary innovations, converting insects, highly nutritious and rich in protein, into palatable food, and making artificial meat. To quote Gandhi, there'll be enough for everyone's need, but not for everyone's greed. Population trends after 2050 are harder to predict. Enhanced education and empowerment of women, surely a benign priority in itself, could reduce fertility rates in the places where they're now highest, in India and in particular in sub-Saharan Africa. But if families in Africa, for instance, remain large, then according to the UN, that continent's population could double again between 2050 and 2100. Nigeria would then alone have a population of 900 million, equal to the population at that time of both Europe and North America added together. And Africa's population would get up to 10 times Western Europe's. Well, optimists say that each extra mouth brings 2 hands and a brain. But it's the geopolitical stresses of that scenario which are rather worrying. Because sub-Saharan Africa can't escape poverty in the way that these sort of Asian tigers, Taiwan and Vietnam, did, by undercutting Western manufacturing costs. Because robots can do that now. And everyone in Africa, they may not have good sanitation, but they do have mobile phones, and they know the injustice of their fate. And migration's easy. This is a recipe for instability. Multiple mega versions of the tragic boat people crossing the Mediterranean today. So, one important message, I think, is that wealthy nations, especially in Europe, should urgently promote growing prosperity in Africa, and not just for altruistic reasons. But so much for population. Now another thing. If humanity's collective impact on land use and climate pushes too hard, the resultant ecological shock could irreversibly impoverish our biosphere. Extinction rates are rising. We're destroying the book of life before we've read it. Already there's more biomass in chickens and turkeys than in all the world's wild birds. And the biomass in humans, cows and domestic animals is 20 times that in wild mammals. Biodiversity is crucial for human well-being. But for many environmentalists, preserving the richness of our biosphere has value in its own right, over and above what it means to us humans. And to quote the great Harvard ecologist E.O. Wilson, mass extinction is the sin that future generations would least forgive us for. So the world's getting more crowded. And there's a second firm prediction. It will gradually get warmer. The famous Keeling curve here, which has measured the concentration of carbon dioxide in the atmosphere over the last 50 or so years, shows this rising trend. The oscillations, incidentally, are because there are more trees in the northern hemisphere than the south. So in the autumn, when the leaves fall off the trees, the CO2 goes up, and that's taken up again in the spring. But the main point is that superimposed on those oscillations, there is this rising trend, which is what, of course, is worrying, because carbon dioxide is a greenhouse gas. And the fifth IPCC report presented a spread of predictions for different assumptions about future rates of fossil fuel use and associated rises in the CO2 concentration. These are fairly familiar graphs. It's important to mention that there are some scientific uncertainties in the feedback effects. We know what the CO2 itself does, but we don't know how the rise in CO2 affects the change in water vapor, cloud cover, and things like that. So the bars on the right-hand side indicate the range of uncertainty for each of the four different scenarios for future fossil fuel burning. I won't go into the details of those, but this does show the range. But despite the uncertainties, the most important message is that under business as usual scenarios, where we go on burning fossil fuels, we can't rule out, later this century, really catastrophic and irreversible warming, and tipping points triggering long-term trends like the melting of Greenland's ice cap. This is what we urgently need to prevent. But of course the trouble is that politicians won't gain much resonance by advocating unwelcome lifestyle changes or a high carbon tax, when the benefits accrue mainly to distant parts of the world and are decades in the future. They will only act if they think voters are behind them. And that's why what matters is what's in their inboxes, what's in the press, and also demonstrations. So we should welcome the recent demonstrations, especially those involving young people, because the young people are those who will still be alive at the end of the century. They are not going to agree with economists who discount the future so much that what happens after 2050 carries no weight. So we should welcome these demonstrations and hope that politicians will realize that the voters are behind them in dealing with climate change, as also they should be in other things like cleaning up the plastic in the earth, in the oceans. But it's a political challenge, and I think there's one win-win roadmap to a low-carbon future, which I'd like to mention. And this is that nations should accelerate their research and development into all forms of low-carbon energy generation and into other technologies where parallel progress is crucial. Energy storage, batteries, compressed air, pump storage, flywheels, hydrogen, etc., and smart grids. Because the faster these clean technologies advance, the sooner will their prices fall so they become affordable to, for instance, India, where more generating capacity will be needed and where the health of the poor is now jeopardized by smoky stoves burning wood or dung. But where, if renewable energy is too expensive, there'll be pressure to build coal-fired power stations. So we need a real crash program to develop cheap, clean energy for the world. Sun and wind are, of course, the front runners, but other methods have geographical niches, tidal and geothermal, for instance. And also, because of local intermittency of wind and sun, we'll need continental-scale DC grids. We need to carry solar energy from the sunny south to the cloudier and less sunny north, and we need to have grids to carry energy east-west to smooth out the peak demand in different time zones. all across North America, and I would hope perhaps all the way from Europe to China as part of the Chinese Belt and Road development. That's what we need. And I mentioned sun and wind, but despite wide ambivalence about nuclear energy, I think it's worthwhile to boost R&D into a variety of fourth-generation concepts, which could prove to be more flexible in size and safer than the 1960s vintage designs now being used. Small modular reactors, for instance. And the potential payoff for fusion is so great that it's surely worth continuing experiments and prototypes of that. Indeed, it would be hard to think of a more inspiring challenge for young engineers than devising clean and economical energy systems for the world. And incidentally, it reminds me that this is a scientific institution and it's engineers who are going to do this. And I'm from engineers, and I'd like to put in a bit of preemptive modesty, speaking as a scientist, because engineers rather like a cartoon in the New Yorker many years ago. And the cartoon showed two beavers looking up at a big hydroelectric dam. One beaver said to the other, "I didn't actually build it, but it's based on my idea." And that fairly truly reflects the balance of effort between armchair theory and what's actually practical and feasible and actually works, which is what engineers do. And we need the engineering, but it must be based on science. And since we're in one of the international temples of extreme theoretical science, I'd like to say I often tell my colleagues that the Swedish engineer who invented the zip fastener made a greater intellectual leap than most of them will do in their lifetime. So that's a bit of modesty, but it really is the case that most of the brain power is needed in the technology and the applied science. And we should be evangelists for new technology, not Luddites. Without it, the world can't provide food and sustainable energy for the expanding and more demanding population we predict. But we need wisely directed technology. Clean energy is one. One that isn't, incidentally, which I should have mentioned, is a plan B if we don't control CO2 emissions. Geoengineering, where we put some sort of dust in the upper atmosphere to cool down the planet. That's something which would cause all kinds of international problems, because different countries will want to adjust the thermostat differently. The only beneficiaries with the lawyers, because if nations could litigate over bad weather, that's a bonanza for them. But geoengineering is something we want to avoid, at least the top kind of geoengineering there. A second kind, where you simply extract the CO2 from the atmosphere, undoing the geoengineering we've done unwittingly by burning fossil fuels. That is benign, but that is very expensive of energy and isn't feasible at the moment. So that's a technology that we don't want to develop at the moment. But we do need wisely directed technologies. And many are anxious, though, that some technologies are developing so fast that we may not properly cope with them. And we might have a bumpy ride through the century. That's another theme of my book. In fact, we're ever more dependent on elaborate networks of all kinds. Electric power grids, air traffic control, international finance, just-in-time delivery, and so forth. And unless these globalized networks are highly resilient, their manifest benefits could be outweighed by catastrophic breakdowns, real-world analogues of what happened to the financial system in 2008. And these could cascade globally. Our cities will be paralyzed without electricity, supermarket shelves empty within days if supply chains were disrupted. Air travel can spread a pandemic worldwide within days now. And social media can spread panic and rumor and psychic economic contagion literally at the speed of light. But what about these new technologies? Advances in biotech Diagnostics, vaccines, and antibiotics offer huge prospects for improving health and of containing pandemics, for instance. But the same research innovations have controversial aspects. Give one example. In 2012, researchers in Wisconsin and also in Holland showed it was surprisingly easy to modify the flu virus to make it both more virulent and more transmissible. To some, this was a scary portent of things to come, and indeed the US federal government stopped funding these so-called gain-of-function experiments. And also the new CRISPR-Cas9 techniques for gene editing are hugely promising, but there are ethical concerns about, for instance, the recent Chinese experiments on human embryos, for instance. And also worries about possible runaway consequences of so-called gene drive, when you can drive a particular species to extinction. That may be fine if it's used to wipe out the mosquito that carries the Zika virus, for instance. That's been tried. But some nasty people have wanted to wipe out the grey squirrel in England because it can't compete very well with the brown squirrel. But of course, if you modify the balance of species, you may have runaway unintended consequences. So this is where we have to be very cautious about what we do. But in applying these powerful techniques of gene editing, gain of function, etc., clearly we need regulation. But I worry that whatever regulations are imposed on grounds of prudence or ethics can't be enforced worldwide any more than the drug laws can or the tax laws. I worry that whatever can be done will be done by someone somewhere. And that's a nightmare. Whereas an atomic bomb can't be built without large-scale special purpose facilities, which can be monitored by inspectors, biohacking involves small-scale, dual-use, widely available equipment. Indeed, biohacking is burgeoning, even as a hobby and competitive game. And we know all too well that technical expertise doesn't guarantee balanced rationality. The global village will have its village idiots, and they'll have global range. The rising empowerment of tech-savvy groups, or even individuals, empowered by bio as well as cyber technology, will pose an intractable challenge to governments and aggravate the tension between three things we want: freedom, privacy, and security. And all these concerns, I think, are fairly near term, within the next 10 or 15 years. But what about 2050 and beyond? On the bio front, we may then expect two things. First, a better understanding of the combination of genes that determine key human characteristics, looks, intelligence, etc. These will be found by using AI to analyze huge numbers of human genomes. But then, having done that, we may have the ability to synthesize genomes that match these features. Designer humans, this is. And indeed, the great physicist Freeman Dyson conjectures a time when children will be able to design and create new organisms, just as routinely as his generation played with chemistry sets. But if it really becomes possible to, as it were, play God on a kitchen table, our ecology and even our species may not survive unscathed. And what about another transformative technology? Robotics and artificial intelligence, AI. As I'm sure everyone knows, there's been exciting advances in generalized machine learning. DeepMind, a London company now bought by Google, achieved a remarkable feat. Its computer beat the world champion in the game of Go, and then in the game of chess, and now beat human experts in optimizing proton folding. And the computer that played Go and chess was not like the computer that beat Kasparov 20 years ago, which was programmed by expert players. It was just given the rules and gained expertise by playing hundreds of thousands of games against itself in a single day. The programmers don't themselves know how the machines made seemingly insightful decisions. It is, of course, here's the human Go player who looked a bit surprised to be defeated, but it is, of course, the speed of computers which allows them to succeed by brute force methods in these games. And computers can learn to identify dogs, cats, and human faces by crunching through millions of images, not the way babies learn. And they learn to translate by reading millions of pages of multilingual text. In Europe, they're given European Union documents. Their boredom threshold's infinite. The social implications, though, of these machine learning achievements are already ambivalent. If we are sentenced to a term in prison, recommended for surgery, or even given a poor credit rating, we would expect the reasons to be accessible to us and contestable by us. If such decisions were entirely delegated to an algorithm, I think we'd be entitled to feel uneasy, even if presented with compelling evidence that on average, the machines made better decisions than the humans they'd usurped. AI systems will become more intrusive and more pervasive. Records of all our movements, our health, and our financial transactions will be in the cloud, managed by a multinational quasi-monopoly. And there'll be other privacy concerns. Are you happy if a random stranger sitting near you in a restaurant or on a train can, via facial recognition, identify you and invade your privacy? Or if fake videos of you become so convincing that visual evidence can no longer be trusted? And the arms race between cybercriminals and those trying to defend against them will become still more expensive and vexatious. These are all near-term concerns. Computers succeed by reinforced learning on these big training sets. But it's not so easy to get them to learn common sense and to learn about human behavior, because that involves observing real people in real homes or workplaces. And the machine would feel sensorily deprived by the slowness of real life and be bewildered. It's like us watching trees grow, because they think so much faster than that. And to quote Stuart Russell, who's a leading expert on AI at Berkeley, I quote, he said, "The machine could try all kinds of things: scrambling eggs, stacking wooden blocks, chewing wires, poking its finger into electric outlets. But nothing will produce a strong enough feedback loop to convince the computer it was on the right track and lead to the next necessary action." So robots can't really learn by watching human beings the common sense and etiquette which are important to all of us. And of course, though they have the advantage of speed, robots are still clumsier than a child in moving pieces on a real chessboard. They can't jump from tree to tree like a squirrel, though a Boston Dynamics robot, there he is, can apparently do somersaults, but in a rather clumsy way. And of course, another context where humans have the edge is that the Go-playing computer used hundreds of kilowatts of power. But the brain of Mr. Lo Kui, the human challenger, uses about 30 watts, just like a light bulb. And he can do many other things, as well as just playing Go. But machines are clearly catching up. Where will they have the biggest impact? They'll take over some manual work, but they won't just take over manual work. Indeed, plumbing and gardening will be among the hardest jobs to automate. But they will supplement humans in professional areas: routine legal work, coding, medical diagnostics, and even surgery. And the big social and economic question is then, will this new machine age be like earlier disruptive technologies, the car for instance, and create as many jobs as it destroys? Or is it really different this time? The money earned by robots will clearly generate huge wealth for an elite of individuals and companies. But I suggest in my book that to preserve a healthy society will require massive redistribution of that income to ensure that everyone has at least a living wage. But this shouldn't be a handout. It should be achieved by creating huge numbers of upgraded public service jobs where the human element is crucial and which are now undervalued and where demand is huge. Among these, of course, I'd especially emphasize carers for young and old, but also custodians, gardeners in public parks, and so on. If enough such jobs can be created and publicly supported to re-employ those now doing mind-numbing jobs in call centres and Amazon warehouses, that's surely a win-win situation to be welcomed. I could see this massive redistribution happening in China, in Scandinavia, maybe in Canada, though I think it's less likely in countries that fetish low tax rates like my country and the United States. But let's now look still further ahead. How human or human-like will future robots be? AI can cope with things where it doesn't have to look human-like at all. It can cope with complex, fast-changing networks, traffic flows or electric grids, for instance. And the Chinese could have an efficient planned economy of a kind that Marx could only dream of. And AI can help science too. Perhaps it can find the recipe for a high-temperature superconductor, or find the best chemical composition for drugs, or settle whether string theory really describes our universe. It can help with all those things. But what if a machine developed a mind of its own? Would it stay docile or go rogue? Popular cultures, of course, portray a dark side, when AI gets out of its box, infiltrates the Internet of Things, and pursues goals misaligned with human interests, or even treats humans as an encumbrance. Well, this is fascinating science fiction, but some AI pundits, of course, take it seriously and think that the field already needs guidelines, just as biotech does. But others, like, for instance, Rodney Brooks, the inventor of the Baxter robot and the Roomba vacuum cleaner, regard these concerns as premature. He thinks it will be a long time before artificial intelligence will worry us more than real stupidity. But be that as it may, it's likely that society will be transformed by autonomous robots, even though the jury's out on whether they'll be idiot savants or display superhuman capabilities. This is the futurologist Ray Kurzweil, now working at Google. He argues that once humans have been surpassed by machines, the machines will themselves take over and design and assemble even more powerful machines. There'll be an intelligence explosion. He wrote a book called The Age of Spiritual Machines, where he predicted that humans would transcend biology by merging with computers. In old-style spiritualist parlance, they would go over to the other side. We then confront the classic philosophical problem of personal identity. Could your brain be downloaded into a machine? If so, in what sense would it still be you? Should you be relaxed about your original body then being destroyed? What would happen if several clones were made of you? These are ancient conundrums for philosophers, but practical ethicists may need to address them later in this century. But Kurzweil is worried that his nirvana may not happen in his lifetime. So he wants, in the meantime, for his body to be frozen in liquid nitrogen. And there's a company in Arizona that will freeze and store your body so that when immortality is on offer, you could be resurrected or your brain downloaded. Others have gone in for this too, and I was surprised to find, in fact, that 3 academics in England, who I know, have gone in for this cryonics. 2 paid the full whack, the third took the cut price option of just wanting his head frozen. I was glad all 3 were from Oxford, not from my university. And I told them I'd rather end my days in an English churchyard than an American refrigerator. But of course, research on aging is being prioritized seriously. We don't know if the benefit will be incremental or whether aging is a disease that can be cured. Dramatic life extension would plainly be a real wild card in population projections, with huge social ramifications. But it may happen, along with human enhancement in other forms. And it's at least surely on the cards that human beings, their mentality and their physique, may become malleable through the deployment of genetic modification and cyborg technology. Moreover, this future evolution, a kind of secular intelligent design, would take only centuries, in contrast to the thousands of centuries needed for Darwinian evolution. And this is a game changer. When we admire the literature and artifacts that have survived from antiquity, we feel an affinity across a time gulf of thousands of years with those ancient artists and their civilizations. But we can have zero confidence that the dominant intelligences a few centuries from now will have any emotional resonance with us, even though they may have some algorithmic understanding of how we behaved. And now I want to turn to another technology, space, my special interest, because it's beyond our Earth, in environments hostile to humans, that cyborg and AI technologies have the most spectacular scope, and where these changes will happen fastest and will worry us less. During this century, the whole solar system will be explored by swarms of miniaturized probes, far more advanced than the wonderful Cassini instrument, designed in the 1990s, which spent 13 years exploring Saturn and its moons, and the European probe Rosetta, which landed a robot on a comet, or the NASA probe New Horizons, which sent back these pictures of Pluto, 20,000 times further away than the moon. Think back to the computers and phones of the 1990s, when the probe that took these pictures was designed, and realize how much better we can do today. The next step also in space will be the deployment in space of robotic fabricators, which can build large structures. For instance, giant telescopes with huge gossamer thin mirrors assembled under zero gravity, and solar energy collectors. But what about manned spaceflight? With all these advances in robotics, the practical case for sending people into space gets weaker. So will manned spaceflight ever be resurgent? It's 50 years since Neil Armstrong's first small step on the moon, and I cherish this picture signed for me a few years ago by 7 of the Apollo astronauts. In the 1960s, there was, of course, a space race between America and Russia. NASA then got about 4% of the federal budget. Had that pace continued, there would have been footprints on Mars long before today. But of course, once the race to the moon was won by the Americans, there was no motive for continuing this requisite expenditure. And NASA now gets about 0.5% of the federal budget. But of course, hundreds more have ventured into space subsequently, but anticlimactically, they've gone into low Earth orbit and no further, and done no more than circle the Earth. Most of them in the International Space Station, shown here. And this really only makes news when something goes wrong. When the loo fails, for instance, or when the Canadian astronauts perform stunts, like Chris Hadfield playing his guitar. These make great public interest. But will there be any inspirational Apollo-style projects? There's no denying that NASA's Curiosity probe trundling across a giant Martian crater and leaving the tracks, which you can just see a quarter of the way up that picture, that may miss some exciting things that a real human geologist would detect. But machine learning is advancing fast, as is sensor technology. In contrast, the cost gap between manned and unmanned missions remains huge. NASA's manned program, ever since Apollo, has been impeded by public and political pressure into being exceedingly risk-averse. The space shuttle failed twice in 135 launches. Test pilots were willing to accept this 2% level of risk, but the shuttle had unwisely been promoted as safe for civilians, and each failure was a national trauma. So, because of the safety culture, NASA will confront political obstacles in achieving any grand goal within a feasible budget. China has the resources, the dirigist government, and maybe the willingness to undertake an Apollo-style program. But leaving aside the Chinese, I think the future of manned spaceflight lies with privately funded adventurers prepared to participate in a cut-price program far riskier than Western nations could impose on publicly supported civilians. Elon Musk's SpaceX and Jeff Bezos' Blue Origin will soon offer orbital flights to paying customers. Were I an American, I would only support NASA's unmanned program. I'd argue that private enterprise ventures like those should front all manned missions as cut-price, high-risk ventures. There'd still be many volunteers, some perhaps even accepting one-way tickets, driven by the same motives as early explorers, mountaineers and the like. By 2100, courageous thrill seekers may have established bases independent from the Earth, on Mars or maybe on asteroids. Musk himself, aged 48 I think, says he wants to die on Mars but not on impact. And he might. But don't ever expect mass emigration from Earth. Nowhere in our solar system offers an environment even as clement as the top of Everest or the South Pole. And here I disagree with Musk and with my late colleague Stephen Hawking. I think it's a dangerous illusion to think that space offers an escape from Earth's problems. Dealing with climate change on Earth is hard, but it's a doddle compared to terraforming Mars. There's no planet B for ordinary risk-averse people. Nonetheless, we should cheer on these brave space adventurers because they'll have a pivotal role in spearheading the post-human future and determining what happens in the 22nd century and far beyond. This is why they'll be ill-adapted to their new habitat, so they'll have a more compelling incentive than those of us on Earth to redesign themselves. They'll harness the super-powerful genetic and cyborg technologies that will be developed in coming decades. These techniques will, one hopes, be restrained here on Earth, but settlers on Mars will be beyond the clutches of the regulators, and we should surely wish them good luck in modifying their progeny to adapt to alien environments. So it's these spacefaring adventurers, not those of us comfortably adapted to life on Earth, who will spearhead a post-human era. And this raises the question astronomers are most often asked. Is there life out in space already, or is the galaxy waiting for our progeny in the far future to spread through it? And of course, electronic intelligences are near immortal. A million-year voyage is no deterrent to them. Well, we all agree that we don't know if there's life out there. Well, not quite all, because I get letters from people who say they've met the aliens, they've been abducted by them. And I tell these people, do they really think that if the aliens had made a huge effort to traverse interstellar space, they'd just meet one or two well-known cranks, make a corn circle and go away again? Seems unlikely to me. And I tell these people to write to each other and not write to me. Well, more seriously, we know that there's nowhere in our solar system where there's any advanced life. There could be some freeze-dried bacteria on the red planet. There could be something under the ice of Enceladus. This is a moon of Saturn. But if we widen our horizon beyond our solar system to the realm of the stars, then prospects are very different indeed and very exciting. We've learnt in the last 10 or 20 years that most stars in the sky are orbited by retinues of planets, just as the Sun is orbited by the Earth and the other familiar planets. But the evidence is mainly indirect. We don't observe the planet, but detect its influence on the motion or brightness of the star it's orbiting. The simplest technique is this, that if a planet moves or transits across the face of a star, then the star dims slightly. And if you observe the star and these regular dimmings, you can infer there's a planet orbiting it. And this NASA spacecraft called Kepler stared for 3 or 4 years at an area of sky containing 150,000 stars and monitored them every hour with a very high precision to find just these effects. And it found literally thousands of stars in its sample which had planets. And this rather silly cartoon illustrates some of the systems it found where this shows to scale the orbital periods and the masses and sizes of the planets. And what we've learnt is that almost every star has a planet around it, and 1 in every 6 stars has a planet rather like the Earth, about the mass of the Earth and about the distance from its parent star, such that water could exist, neither boiling away nor staying frozen. And there are some very strange systems. This is a system where there are 7 planets orbiting around a very faint star called an M dwarf. It's a miniature solar system. The star's 1% as bright as the Sun, and these 7 planets have years, which are from 1.5 Earth days to about 20 Earth days. And these planets, because they're close, and they'd be tidally locked, presenting their same face to the Sun, rather as the Moon presents the same face to us. So half of the planet, if we lived on it, would be in brightness all the time, one in perpetual darkness. So I guess it'd been a kind of apartheid. Everyone would live in the bright half, except the astronomers would be on the other side, in the dark bit. We don't know what these planets would look like. This is just an artist's impression. But the trouble is, we now only infer these planets indirectly from their effect on the star they're orbiting. We'd like to actually see them. And that's a big challenge. To imagine the challenge, let's suppose that there were some aliens with a big telescope, say 30 light years away from the Earth. They would see our Sun as an ordinary star, and they'd see the Earth as, in Carl Sagan's nice phrase, a pale blue dot, very close in the sky to its star, our Sun, but billions of times fainter. But if their telescope was powerful enough to actually observe the pale blue dot, you could learn quite a bit about it. Because the shade of blue will be slightly different depending on whether the Pacific Ocean or the landmass of Asia was facing them. So they could infer that there were continents and oceans, the length of the day, and by analysing the light carefully, they could infer there's oxygen in the atmosphere and maybe lots of green stuff on the land. We can't do that yet, but within 10 or 20 years, we'll be able to draw inferences just like that about Earth-like planets around other stars. This will be done partly by the Space Telescope, the James Webb Telescope, but rather better by this telescope being built by European astronomers. Europeans are not very imaginative in their nomenclature. It's called the Extremely Large Telescope. And it's being built now on a mountaintop in Chile, and it's got a mirror which is 39 meters across. And that's bigger than the length of this lecture room, I'd guess. It's a mosaic of 800 pieces of glass. And this will have the combination of resolution and sensitivity to actually analyze the light from planets like the Earth around nearby stars. And that will indeed be very exciting. But of course, habitable doesn't mean inhabited. But for most of us, that's the number one question. Although we know there are lots of habitable planets, we don't know the likelihood that they will have life on them. That's because we know not much about how life got started on Earth. We understand Darwinian evolution, but we don't know what triggered the transition from complex chemistry to the first metabolizing, reproducing system we could call alive. We don't know if it's a rare fluke or whether it would have happened in any environment like the young Earth. And of course, we know even less about the likelihood of intelligent life. Even if we had simple life being widespread, intelligent life could still be rare. But it's such a fascinating question that I think these SETI searches are well worthwhile, even if the chance of success is small. And I'm actually the chair of an advisory group for Yuri Milner's Breakthrough Listen project, which is trying to do this. But that's a topic for another lecture, or maybe for the question period. I want now to indulge briefly in some speculations on the really far future, bearing in mind that I'm speaking in an institution that thinks about the more speculative kinds of cosmology. First, let's think about timescales. This is a familiar time chart showing the history of life on Earth, taken about 4 billion years for us to evolve. Many people who are familiar with this somehow think that we humans are the culmination of it all. But no astronomer could believe that, because our sun is less than halfway through its life. It'll have 6 billion years more before it dies. Any creatures witnessing the demise of the sun, when it will look something like this, will be as different from us as we are from slime mold. And of course, even when the sun dies, the universe will go on expanding, maybe forever. To quote Woody Allen, eternity is very long, especially towards the end. So, because of these vast expanses of time in the future, even if life had originated only on the Earth, it need not remain a trivial feature of the cosmos. Humans could jumpstart a diaspora whereby ever more complex intelligence spreads through the whole galaxy. Vast self-reproducing machines, transmitting DNA, instructions for 3D printers or such like. Interstellar voyages would hold no terrors for near immortals. And this has implications for SETI searches, because if the emergence of intelligence on another world had followed a similar evolutionary path to what's happened here, then were we to detect ET, we'd be most unlikely to catch it in the brief sliver of time when it was still in organic form. Because on our Earth, there's been 4.5 billion years before technology emerged. It's been around for a few millennia. Maybe in one more millennium, it'll be superseded by electronic intelligence, which will then go on for billions of years. So that means that it's far more likely, if we detected something artificial, it would be not an organic civilization, but something which was created by a long-dead organic civilization. That therefore means, incidentally, if we discovered something artificial, it's most unlikely that it would be a signal that we could decode. It would be so alien from human beings. Maybe a byproduct or even a malfunction of some super-complex interstellar technology that could trace its lineage back to alien organic beings, but they might long ago have died out. Well, let's now widen the horizons even more to the entire cosmos, which could eventually be within the range of post-humans. The death of stars would be no impediment to them. nor the merger of our galaxy with Andromeda. In 4 billion years, what will happen will be like this train crash here, two galaxies merging together. This simulation shows what happens, and Andromeda will hit us in about 4 billion years. And if we look further away, we see that there are many, many billions of galaxies that we can see. And these galaxies, an emerged remnant of us and the Andromeda galaxy, will persist for hundreds of billions of years. Time enough, perhaps, to approach the peak intelligence limit, where all the atoms that were once in stars could be transformed into some vast structure as intricate as a living organism or a silicon chip. But even so, even with all this, some parts of space-time would still be unreachable. We can see billions of galaxies here, each harboring billions of planets. But it's still only a finite number. Observations are constrained within a horizon. There's a shell around us which delineates the limit of the distance light can have traveled since the Big Bang. But that shell has no more physical significance than the circle that delineates your horizon. If you're in the middle of the ocean, you don't think the ocean necessarily stops just beyond your horizon. So the observable universe is only a fraction of the aftermath of our Big Bang. We'd expect far more galaxies located unobservably beyond our horizon. Most astronomers would guess that galaxies extend at least 100 times further, but that's just a minimum. It could extend so far that all combinatorial possibilities would be repeated. Far beyond the horizon, we could all have avatars, making the right decision when we make the wrong one, which may be some minor comfort to you. But that's not all. Our Big Bang may not be the only one. As is illustrated in this cartoon, it could be just one island in a vast cosmic archipelago. This is Andrei Linde, the Russian cosmologist's idea of eternal inflation. And there are many other ideas. These multiverse ideas are still speculative physics. That's because we don't have a battle-tested theory which describes the very beginning of our Big Bang. And indeed, a challenge for 21st century physics and for this institution is to see which part of this decision tree is correct and to address two fundamental questions. First, are there many Big Bangs or just one? Second, if there are many, are they all governed by the same physics? Or could other Big Bangs have cooled down differently, ending up with different geometry, different particles, forces of different strength, and so forth? In the latter case, many universes could be stillborn or sterile because the laws prevailing in them might not allow any kind of complexity. We therefore wouldn't expect to find ourselves in a typical universe, but a typical member of the subset which allows complexity to evolve. This is what's called anthropic selection. And in this case, what we call the universal laws may, in the grand perspective of the multiverse, be just parochial bylaws in one cosmic patch, as it were. So just as Earth may be a very special planet among zillions of others, so on this far grander scale, our Big Bang may have been a special one. Some physicists foam at the mouth at this idea, but our preferences are irrelevant to the way physical reality actually is. We don't know which branch of this decision tree is correct and should surely be open-minded. Space and time on the grandest scale could have a structure as intricate as a rich ecosystem. Our current concept of physical reality could be as constricted as the perspective of the Earth available to a plankton whose universe is a spoonful of water. About 10 years ago, I was on a panel at Stanford University where we were asked by the chairman, Bob Kirshner, how much we'd bet on the multiverse concept. He asked, how much would you bet on a scale? Would you bet your goldfish, your dog, or your life? I said I was almost at the dog level. And Andrei Linde, who had spent 25 years promoting eternal inflation, he said he'd almost bet his life on it. And later, on being told about this, the great theorist Steven Weinberg said he'd happily bet Martin Rees's dog and Andre Linde's life. Well, Andre Linde, my dog, and I will all be dead long before this is settled, but it's not metaphysics. It's highly speculative, but it's exciting science, and it may well be true. Well, fortunately, I've not got more time to get more deep into speculations, so let me end by zooming back in from the universe, even from an ensemble of universes, to the realities here and now. Even in the context of a concertina timeline, stretching billions of years into the future as well as into the past, then, as I said at the beginning, this century is special. It's the first when our species had the planet's future in its hands. And we could inaugurate this transition into post-human evolution, even more marvelous than what's led to us. On the other hand, if we screw up, humans could trigger bio, cyber, or environmental catastrophes that foreclose all such potentialities. So technology, as I've emphasized in my book and all through, needs to be wisely directed, and directed by a set of values which science itself can't provide. So my final conclusion is that our Earth, this pale blue dot in the cosmos, is a special place. It may be a unique place, and we're its stewards at a especially crucial era. And that's an important message for us all, whether or not we're astronomers. Thank you for listening.
Very good. Thank you so much. We're going to open the floor to questions. So for those in the theater, the microphone is right there. And online, I have a whole list of questions. So we'll start here. Martin, here's the question. It's easy to get pessimistic given all the challenges you've described. How do you remain optimistic for humanity?
Yes. Well, cheerfulness does keep breaking in, of course, as Dr. Johnson said when he was asked why he wasn't a philosopher. But I think we must realize that probably for most people, this is the best time to be alive. Some people, of course, were fine in the past, but far more people are leading reasonably happy, comfortable lives now than in any previous generation. So we shouldn't be pessimistic about that. But what does make me a bit pessimistic is that although clearly the lives of people today are much better than the lives of the average person in medieval times, the gap between the way things could be and the way they are is much wider. In medieval times, there wasn't very much they could do to improve things. Whereas now, there is a huge amount we could do to make a better life. And to take one example, the wealth of the 2,000 richest people in the world would be sufficient to double the income of the bottom billion in the world. And the fact that that's not happening is one of many ethical indictments of our current civilization. So I think we can be happy that there is an improvement, but I think we must be pessimistic about the gap between the way things are and the way they could be.
Thank you. Let's go in the theater here.
Hi there. I just want to preface this by saying I'm not an expert on any of this and definitely not one of the smartest people in the room. You touched briefly on designer babies. And I think a lot of us would agree that having a designer baby to prevent a heritable disease would probably be okay. And maybe even someone who just was a little on the slow side, or maybe, was really short, or just could use a little tuning up. I'm sure some of us would be okay with that. But I think a lot of people get really uncomfortable when you start getting people above average. Like the people that can eat anything they want and still stay skinny, the people who will learn something overnight and be smarter than you. When we're able to do that, that would cost a lot of money. So the rich are no longer getting richer, they're also getting smarter. And do you think that would be ethical? Or where would you stop that?
No, but if I had more time, I'd have said exactly what you've just said. I think it's certainly acceptable to gene edit if it's something like Huntington's disease, where changing one gene can save people from a fatal disease. But of course, the Chinese case, when they reduced propensity to HIV and possibly led to others, that was thought not to have the same balance of benefits over risks. And of course, when we come to the stage, being able to design humans, and that'll be quite a long time in the future, because we need to understand the genome and attributes that depend on many, many genes, then of course there is going to be the issue of, is it ethical, and if it's allowed, will it lead to a more fundamental kind of inequality than we have now? So indeed, that is a very deep ethical question, I think, and that's why I rather hope that that will be effectively regulated and left to the crazy guys on Mars. Let them do it.
Thank you very much.
The next question right here.
Hello. You mentioned how the poorest billion can and should be lifted out of poverty by redistribution of wealth from the wealthiest 2,000. Of course, the wealthiest 2,000 will never agree to such an arrangement voluntarily. So are you in fact calling for expropriations, doing away with capitalism and switching to socialist economy? And I hope that you do.
I didn't quite catch the last bit.
Do you in fact call for expropriation of wealth and doing away with capitalism and switching to a socialist economy of some sort?
I think the answer is yes. I think the inequalities are gross and should be reduced. And I think they could be reduced tremendously without eroding incentives, etc. So I certainly think that the growth in financial inequality is damaging to the health of society, and it could be reduced and should be reduced, yes.
Thank you.
Thank you. All right, here's an online question. I just lost it, but it's coming back. There seems to be a rise in anti-scientific sentiment lately. How do we compact this trend in favor of science?
Well, this is a difficult question. I think, again, let me be optimistic. I'm gratified by the amount of interest in science, even the science which is far from everyday concerns. I mean, for young kids, dinosaurs and space are the most popular topics. And that it illustrates how people are fascinated by the wonder of these things, and that should be encouraged. I think one of the troubles is that in the era of social media, extreme and ill-informed opinions get more traction more easily. This, I think, is the origin of populism, that in the past, the public media, like the newspapers, they were filtered by reasonably competent people, and so the extremes were damped out, whereas now the reverse is the case. And I think that's also true of the extremes of anti-science, that they along with all other kinds of extremes, flourish on the internet. But I think, since you mentioned science, I think it is very important that everyone should have a feel for science, because, as I think I indicated, most of the decisions that have to be made by politicians, if they involve, say, health, the environment, energy, they all involve some science. They involve economics and ethics as well, but they involve science. And so to be an informed citizen, people need to have some feel for these subjects, as also they need to have some feel for numbers, so they can't be bamboozled by bad statistics. So everyone needs to have some scientific background. But I'd also like to say that apart from it being important for a citizen, it's part of our culture. I think it's a shame if people don't understand about Darwin and about the cosmos, etc. Science is part of our culture, and it's the only universal culture. It straddles all boundaries of faith and nationality. And that therefore means it's something we all have in common, and that's a further reason for trying to hope that most people have some feeling for it and appreciation of it.
Thank you. And question here.
Given your extensive experience both in research and in politics, and more particularly your advisor role, I'm curious to know if you have any strong recommendations for how we can coordinate multinational efforts with respect to innovation in this space. And the motivation comes from a place of the fact that a lot of, as you said, social media is pervasive.
Yes.
And the fact is a lot of millennials as well as Generation Z, those under 18, are very interested in sort of this vision for a transhumanist future. Mm-hmm. And we live currently in a society where the structures are either difficult to navigate or seem at odds with each other. And so to rephrase the question for simplicity, what is your recommendation for multinational collaboration?
Yes. Yes. Well, I'll answer. I won't talk about the more futuristic transhuman part of your question, but I think it is clear that we need to have more organizations rather like the International Atomic Energy Agency and the World Health Organization to cope with environment and energy and probably with AI. Because the multinationals straddle national boundaries, and if one wants to regulate them, it's got to be some international body which does that. So I think we do need to have these multinational bodies, and also because many of the problems which confront us on environment and climate, etc., can't be tackled on a national basis. They've got to be tackled multinationally. So clearly we do have to give up some of our sovereignty. One exception, actually, one reason why I plugged the idea of R&D into clean energy being speeded up is that that's one example where you don't need cooperation. It's in everyone's interest to be first in developing some exciting new kind of clean energy because they get the world market. And I preach this when I'm in Britain because Britain has been ahead of most other countries in having legislation to move towards zero carbon by 2050. But of course, even if we do that, then we are only 1% of the problem. But I think our country has perhaps produced more than 1% of the world's clever ideas over the last 200 years. And if we really focused on energy, then perhaps we could, as indeed could Canada, do more to reduce CO2 emissions by helping India and China to cut theirs rather than cutting our own.
Thank you.
All right, one last question, and I say it with a bit of a wink and an apology, but it's got 3 stars, so I have to read it. Do you think we will ever discover or even encounter intelligent life elsewhere in the universe? And if so, what would that mean for humanity?
Yes. Okay. Well, I did sort of allude that, but let me just say a bit more that I think, again, we just don't know. It could be that technology is so rare that it only really happened from the flesh and blood creatures which have evolved on this planet, but many people think that's unlikely, and therefore it's worth having a look for any kind of artificial seeming artifacts and artificial seeming emissions from objects. So this is the SETI program. But I think the one take I would put on this is that if we do detect something, then the scenario I gave for the evolution of on this planet, which is 4 billion years, emerging technology of a few thousand years, and then the machines take over, that suggests that if we detect something which is manifestly artificial, it's not going to be a flesh and blood civilization. It's going to be some electronic artifact, maybe left behind or evolved from that civilization. And this means that it's most unlikely that it will be some sort of decodable message. It's very unlikely. And incidentally, people probably know about the so-called Fermi paradox, which says, if there are lots of aliens, why aren't they here already? Why haven't they come and eaten us, etc.? This is a sort of worry. And some people say we shouldn't send out any signal because they would say we're there. But they know we're here already if they exist. They're more advanced than us. But I think the point I would make is that if the future intelligences are sort of intelligently designed automata, probably electronic, then they'd be different from us, because our emergence has required a combination of intelligence and aggression. But the evolution of these post-human electronic intelligences may lead to developing intelligence, but there's no reason why it should lead to aggression. And so one answer to the Fermi paradox is that there are lots of these entities out there. They're all living contemplative lives, and they're not aggressive, and they're out there, and they're so different from us we haven't noticed them.
Ladies and gentlemen, Sir Martin Rees.